Hello. So we had a question we didn't get to in the review in the diagnostic exam for AP chemistry. So that's what we're talking about right now. It was question 31 from chapter 10 in a diagnostic exam on page 21 in your 5 steps book. So you can see it here. Which of the following are paramagnetic? Okay, so what is paramagnetic? Well, paramagnetic is partially filled shells, and there's another kind of shell which is diamagnetic. Diamagnetic meaning that it's a completely filled shells. How do you remember which one is which? I remember which one is which because para starts with par, which is partially. So paramagnetic is a partially filled shell. Okay, what does that mean? Well, partially filled shell means that you have a shell or a subshell that doesn't have all the electrons in it that it could. Okay, so an example of that would be, let's say we had 1s. It had only one electron in it. That's a partially filled shell. There's only one electron in there. There's a second one going down. So that would be an example of a paramagnetic element. That's hydrogen. Right? It's paramagnetic. I don't see hydrogen in the question. Whereas diamagnetic would be its next door neighbor, helium. Right? Because helium has 2 electrons in the 1s shell. So those 2 electrons represent a completely filled shell. It's a completely filled S subshell, and it's also a completely filled first period. So it's kind of a neat one where it only takes 2 electrons, but that's as much as you can fit in the first primary shell, shell 1. Okay, principal quantum number 1. So let's look at our examples over here. Now, how do you figure this out quickly? The easiest way to figure out if it's got a full shell or not is by looking at where it is on the periodic table, because the periodic table is organized by shells and subshells, right? So we have our S subshell here. We have in the middle the D subshell all the way to zinc and down. Then we have our P subshell over here. And then helium is actually kind of in a weird spot because it should be right next to hydrogen. If you're talking about the S subshell, it's part of the S subshell, 1s2, okay? So knowing that, we can identify quickly from these guys if they have a full shell or if they have a partially or paramagnetic shell. So looking first at beryllium, you'll notice beryllium is actually a S2 configuration. These are all S2 configurations. Okay, so beryllium, magnesium, calcium, strontium, barium, those all represent a completely filled shell diamagnetic. So beryllium actually is diamagnetic. I'm going to say dia for that. Oxygen is not. Oxygen's smack dab in the middle of the P subshell. So it's a P1, 2, 3, 4. It's a P4. P6 is completely filled. So that's a partially filled shell. I'm going to use color coding. Let's use color coding. So paramagnetic will mark as red. Diamagnetic will mark as green. Okay, so the beryllium was diamagnetic. It was a 1s2, but the oxygen is a P It's 1, 2, 3, 4. P4 configuration, not P6. So it's a partially filled shell. Nitrogen is right next door. Nitrogen is a P5 configuration. So it is also going to be a paramagnetic. Moving to the next one, B, we have magnesium is in the S2, just like we saw with beryllium. So that's diamagnetic. Helium is a noble gas. Noble gases are at the very end of the table. They are all P6, or helium is a S2, which we already talked about is our example of a diamagnetic atom. And then we have rubidium, which, oops, that one is not. Rubidium is S1 configuration. These are all S1. The S subshell can take 2 electrons. So, sorry, bud, you didn't make a cut. You are partially filled paramagnetic. Moving down to the next one, we have potassium. Oop, we messed that one up right away. Potassium is a S1 as well, so it's represented as a partially filled shell or paramagnetic. Carbon also messes it up. It's 2 over in a P shell, so it's P2 configuration. Messes its chances up of being a diamagnetic compound. And iron as well is a, this one's different. It's in a D shell. How many electrons can you fit in a D shell? That's right, 10. You can tell because it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 atoms across. So it can fit 10 electrons, or D10. Iron is in 3D10. It's not 3D10, sorry. It's 3D 1, 2, 3, 4, 5, 6, 6. It's 3D6. That's a half filled. No, it's not. Not even half filled. That's a D6 configuration, not filled. It's so red on the chart here. All right, looking at D, we have bromine. Bromine is really close to being a P6 configuration. It's a P5, which is what makes it so darn reactive, because it wants that last electron really badly to make it a full shell diamagnetic compound. Antimony, buried down in here, is in the middle of your P block, and it's partially filled because of its configuration. It's a D, let's see, D1, 2, 3. Sorry, P1, 2, 3, P3 configuration. And then we have chromium. No, Jesus, it's krypton, guys. Krypton's over here is a noble gas, and that is a P6. It's a noble gas. Noble gases do not react with anything because they have a full shell. So they have a diamagnetic or a completely filled shell. So after going through all of those, you can see that it comes down to C. C is the only one that has all partially filled or paramagnetic electron configurations, with potassium being an S1, carbon being a P2, and iron being a D6. D needs 10, P needs 6, and S needs 2. So they don't fit any of those requirements, and therefore they are all partially filled or paramagnetic. So C would be the right choice for that. Hopefully that helps you out.